Hello Year 10 and welcome to our video on 8-01 direct proportion. Later in the week I'll do one for 802 and then in the Zoom meeting I'll talk about both of those. Okay, so with 801, here's what the textbook says and here's what my summary of everything is that we need to consider. So the first thing with direct linear relationship, that means basically if one element gets bigger, so does the other one. Or if one element gets less, so does the other one. And there are quite a few things in real life that exist where something increases and it's tied to something else. Like in my first example here, but I'll get to that in a minute. So direct proportion means one element gets bigger and the other so does the other one. Like in this one here, it's the number of kilos and how much they cost. And in the same way, if something gets less, so does the other one. Okay, that's the first element, what direct proportion means. The wording order of the question. So here it says, y is directly proportional to x. So y comes before x, or y varies directly with x. They mean the same thing. Varies directly, directly proportional, same thing. Okay, means the same thing, just different wording. And that order, as I said, is important, but we'll get to that in a minute, more of that in a minute. The third thing is, what is this k? Because it talks about k here, and the textbook also talks about k. Basically what that is the link between the two things. It's basically saying how much does one element increase for every one of the other one increasing. K is the link between the two. Hopefully this will become clearer once I have a look at this example. And then there's the equation. The general equation is y first, because the order is important. Y directly proportional to x. Y equals k x. Okay, yep, there is y equals kx. Please don't freak out about k yet. Just see what the example comes up with. But k is the link between these two. And then we apply the equation to other stuff. Okay, that's enough of that. Let's have a look at first example. And hopefully all this will become clearer. The cost of purchasing bananas varies directly with the weight. It's simple matter of fact. The more number of kilos you buy of bananas, the more it's going to cost. So in each question, it gives you the order, cost first, weight second, and the two words varies directly, same as these words here, varies directly. So we can, and then it gives you, so that's the wording of the question, cost varies directly with the weight. And then it gives a scenario, 3 kilos for $3.50. So cost is $13.50 and the weight is 3. Okay, that makes sense. Now this one here, variation, this is our equation idea. Variation equation for the cost. Well, that means now, over here we put y first and x second. Here it's cost first and weight second. So the cost equals k, which is what we're going to find out, times the weight. W for weight, C for cost. Now, that means that we can put these numbers here into here, and we can find out what k equals, the link. So wording, cost varies directly with weight, gives you the scenario. So we start with this and we go use these numbers here in the here to work out what K is. So it tells you that cost is $13.50 equals something times the weight. There we are. $13.50 equals K times 3. Whatever the K is our link. So $13.50, 3 kilos, what's the K? So now what we do, since we want to find out what K is, we simplify this side by dividing by 3. So we do this, divide by 3. So steps so far, just to go over, the order is cost first, weight second, cost first, weight second, and whatever that is depends on what we come up with these. Cost $13.50, weight 3 kilos. Cost first equals whatever that is times 3. That's our weight. Cost equals something times weight. To simplify that, we just divide that by 3 because that'll give us how much per kilo. Divide by 3. And what does that equal? Let's find a calculator. 1350. Oops, clear. That's going to be coming up with lots of decimal places. That's okay. Oh no, it's all good. 4.5. That's what K is. That's $4.50 per kilo. So that divided by 3 is 4.5. Or I'll put it in money terms. So K is 4.5. So then, after we've done all that, we can write this. The variation equation for using to apply to these two. Going back to here, now we know what K is. So what we're going to do is use this scenario to work out these. So after all that, the cost equals 4.5 times the weight. Whatever the weight is, you multiply by 4.5, you're going to get how much it costs. That's the variation equation. So to get it, we've got to do this process, which I'll go back over in a sec. Cost of purchasing 1.75 kilos. Okay, so now we know what K is. We can do this. We're looking for the cost. The cost equals 4.5 per kilo times 1.75. 1.75, so 4.5 times 1.75, what's that equal? $7.875. Well, that's dollars, so we'll just take it to $7.88. Equals $7.88. Okay, how many kilos this time? So we know what the cost is, $10. So instead of $10 for the cost, we know the link is 4.5 times how many kilos we are. How many kilos can you get for $10? So let's have a look here. What we do here to simplify all this, 4.5 times how many kilos? In this case we've got to divide to simplify that. So 10 divided by 4.5 will give us how many kilos? $10 divided by the column link will give us how many kilos we can get. 2.2222, or just 2 decimal places, 2.22 kilos. So in other words, 2.22 kilos of bananas cost $10. Okay, let's go back over here. Just do this again. So we get the wording first. Cost something something varies directly. So that's first, that's second, that's third. Then you get the scenario to help us work out what the link is. The K is the link. I've got to work out what it is. And so we do the equation C equals KW. And because of this, we know two of those three things. We know what the cost is. We know what the weight is. So I put, instead of C, we put 1350 equals something times 3. When we divide by 3, we work out what the something is. 4.5, $4.50. So then we can rewrite this looking like this. In fact, I'll just redo that. Now we know what K is. It's 4.5 from this W. That's the variation equation. Then we can use this to work out these other two things. So this first question after that, cost, what's the cost? We don't know what the cost is, but we know what the link is, and we know what the weight is. Link times the weight equals cost. And working the other way, if we know what the cost is, and we don't know what the kilos are, how much can you get for $10? There's the cost equals the link times how many kilos, and then you just divide. Okay. This is our textbook question, example number 2. So let's have a look. Distance in meters travelled by a car is directly proportional. So in other words, the same as varies directly. Same thing. The number of rotations of its tyres. So how many times does a tyre go around once? Then, so that's the first thing, there's our statement, just like here. That was my scenario statement. Here it is. 3 kilos for 1350. This one, we got 450 rotations, distance of 950 metres. Okay, so the distance first equals the link times the rotations. That's the order. Distance first, directly proportional is second, rotations is third. First, second, third. So we've got to find the link using the scenario. Okay, so distance is 950. Meters equals the link, whatever it is, and this link will find out how far we travel for every one tyre rotation. Rotation 540. Distance, link, rotations. Then we divide, getting that, that divided by that will give us what K is. And then we can use that to work out these other two. Okay. $950 over 540. Let's go. Let's do 2 decimal places. 1.76. Looks like to go. 1.76. That means, the link means that the car travels 1.76 metres every time a tyre goes around once. That's the link. Okay, so the equation doesn't ask us to do that, but the equation would be distance equals 1.76 times the number of rotations. Okay, part A will do down here. Distance correct to the nearest metre will be travelled after 800 rotations. So we're looking for distance. We know the link. That seems to make sense. 800 rotations, that's how far for one. So those two will be 1408. 1408 meters. Part B. How many rotations this time to cover 360 kilometers? I'm going to go, that's a lot of kilometers. And we did this according to meters, so we better do that in meters. Equals, because that's how many meters times the rotations. Yep. So we better do, that's a tricky one. Kilometers, got to change that to meters. Okay. So that's how many meters. 360 kilometers is that many meters. Equals 1.76 times how many rotations. So we're just going to divide. Divided by 1.76 will give you how many tire rotations. Divided by 1.76, that's a lot. How many full rotations? Oh, okay, full rotations would be that one. That's only halfway through, so you'd have to go to the next one. 20,204,546. 204,546. There's our two examples. Thank you.